Hello, this is Mr. Stansbury. I'm going to take you through the notes on theoretical probability. At the end of this, you should be able to say, I can find the theoretical probability of various experiments. Okay? Outcomes are equally likely if each outcome has the same chance of happening. For example, tossing a coin, probability of getting heads is 1/2, probability of getting tails is 1/2. So there's 50-50 chance of getting either one of those. Another example is tossing a six-sided die. Probability of getting a 1 is 1 out of 6. Probability of getting a 2 is a 1 out of 6. And then so forth and so on. Okay, so if a sample space has n outcomes that are equally likely, then each outcome has a probability 1 over n of occurring. So again, using the dice example here, there are 6 sides. Since they're all equally likely, it's going to be 1 out of 6 chance that you'll roll any one of those numbers. If it's a 10-sided die, it's going to be 1 out of 10 for each one of the different numbers. Okay? Okay. Example 6. A marble is randomly selected from a bag that contains 4 red, 6 green, and 5 white marbles. Determine the probability of selecting a white marble. So first thing, in our bag, we got to figure out how many total marbles are we going to have. So 4 plus 6 plus 5, there are 15 total marbles in there, right? So let's do this. On the bottom is always going to be the total things that you're choosing from, total possible outcomes, so that's 15. And then how many of those are white? 5 of those 15 are white. So if you simplify that, that's 1 out of 3, or 33.3% chance. Okay, so really the probability, our best bet is our reduced fraction, 1 out of 3. Okay, or again 0.33, 33.3%, any one of those really is fine. Okay, so what's the probability that we reach in and get a red or a green marble? So we're still choosing from 15 marbles. We have 4 red and 6 green, right? So that's going to really be 4 plus 6, which is 10 out of 15, which is going to end up being 2 out of 3 chance, or 66.7% chance of getting a red or a green marble. Okay, what is the probability of getting a red, green, or white marble? So look at that. That is all of them. So red, 4 plus 6 plus 5 out of a total of 15. That's 15 out of 15. So the probability of drawing a red, green, or white marble is 1, or 100% chance. Okay? And then what is the probability of drawing an orange marble? Well, since there's no orange marbles out of the 15 in the bag, that is going to have a probability of 0, or 0%. Okay? All right, let's take a look at another example here. Example 8. Illustrate the sample space with a 2D grid and a tree diagram for spinning the 2 spinners. And then determine the probability of each of the following. So we're going to make a 2D grid and a tree diagram. Okay, this is going to be really fairly helpful because this will help you decide which way is going to be easiest to help you figure out the probabilities. So let's draw those. Okay, so here's our 2D grid and our tree diagram for these two, the 2 spinners, for spinner 1, spinner 2. Okay, so both are really officially displaying the same information, just a different way. Okay, so now from this we can determine what is the probability of spinning a 4 on spinner number 2. So what we could do on the grid here is, here's spinner number 2, and if we're going to spin a 4, that's going to be all of these here. Spin a 4 on spinner 2. So that's going to be, from this here, is going to be 3 out of the total. There are 4, 8, 12 possibilities. So 3 out of 12, or 1/4, or 25% chance. Okay? Now we could also do that on here by, we're looking to spin a 4 on spinner number 2. So that would be, here's our 4, 4, and 4, and that is also 3 out of a total 4, 8, 12. 3 out of 12 possible. 3 out of the 12 possible outcomes are spinning a 4 on spinner number 2. So again, same exact thing. So that's two different ways to find the same answer here with the 2D grid and the tree diagram. All right, so let's do this. Let's take a look at B here. Spinning a 2 on both spinners. So if we're spinning a 2 on both spinners, let's see if we can get rid of some of this extra stuff here so it's not as confusing. Okay, spinning a 2 on both spinners. So spinner 1, we'd have to spin a 2. So that would be all of these here. And then on spinner 2, we also have to spin a 2. So that would be all of these here. Okay, now it's spinning a 2 on both spinners, so it has to be where they intersect, so it's where they both hit. So it's just this one spot right here. Okay, so that's going to be 1 out of the total 12 possible outcomes. Okay, if we were to do that on this one here on the tree diagram, that would be spinning a 2 on the first one and spinning a 2 on the second one. That would be this here. And that is also only 1 of the 12 possible outcomes. Okay, so that's how you could calculate the spinning a 2 on both spinners with a 2D grid and a tree diagram. Okay, and then the last one on this here says, what's the probability of spinning a 2 on spinning a 2 on at least one spinner. Okay, so that would still be these two. That's spinning a 2 on spinner 2. This is spinning a 2 on spinner 1. And then so now, since it's saying spinning a 2 on at least one spinner, that would be all of these dots that we've got circled here, right? So 1, 2, 3, 4, 5, 6 of those. So that would be 6 out of 12. Which is 1/2 or 50% of the time. We can go through and calculate that percent there. We never did that. We should do that. And we get 1 divided by 12 is 8.3 or 8.3% on that one there. Okay. The way to see if we get at least one spinning a 2 on at least one spinner here would be, say, okay, let's see, here's at least 1, 2. All of these here got a 2 on the first one, so all of those would work. And then here's a 2 after spinning a 3 on the first one, so that is 1, 2, 3, 4, 5, 6 out of 12 as well, which is 1/2 or 50%. Okay, so that's using the grid and the tree diagram to figure out the two possibilities. So it's kind of nice to look at this, then you can kind of get your preference down as to what you like. Okay, it also depends on what kind of problem you have. So example 9, display the possible results of rolling 2 8-sided die and their values are added together. Then find the probability that, and then we'll find all this here. So we could do this with a grid or a tree diagram. The thing with a tree diagram is we would have 8 branches to start with, and then we'd have 8 branches off of each of those. So that would take quite a while to do. So I would think it's going to be much easier to do a 2D grid on this. So let's draw one of those. Okay, so here's what the 2D grid would look like officially here. But something that's going to help us more than just making these dots here is it says rolling 2 8-sided die and their values are added together. So what I'm going to do instead of putting these dots in here is I'm actually going to put the sums of each of these because we're going to add the 2 dice together. So let's go back. I'm going to go back and change that into all the sums. Okay, so this is what it looks like instead here. Okay, so it says find the probability that the sum of the dice is 11. So if we're going to go through and find the sum of the dice is 11, look, here's an 11. And look, it's all down this diagonal right here. Right? All of those are 11. So there are 8 times 8. There are 64 different possibilities, and 1, 2, 3, 4, 5, 6 of those 6 of those 64 possibilities are that has a sum of 11. Okay, so again, we can reduce that down to 3 out of 32, right? And then if we calculate that out, we get 3 divided by 32, which gives us 0.094. Oops. 0.094 or 9.4%. Okay? All right, let's take a look at B here. Okay, B. Find that the sum of the dice is less than 5. So that would be 2, 3, 4, right? All of these here. So that would be all of those there. So that is 1, 2, 3, 4, 5, 6. So that is also 6 out of 54, which would be 3 out of 32, which is 0.9. Oh, I did it again. 0.094 or 9.4% for that one as well. Okay, and then let's take a look at C here. Okay, and then C here, the sum of the dice is 3 or 10. So that would, here's our 3s, and then or 10. So either any one of these would work, right? So that is going to be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 9 out of 64, right? Which is 9 divided by 64 gives us 14.1%. All right. Okay, so that's going to be it for the first half of theoretical probability. There will be a part 2 of this video here. So if you have any questions on this, please feel free to ask in class. Thanks.